How does artificial intelligence process human sight and sound simultaneously? In this lesson, we decode the architecture of multimodal neural networks. Welcome back to the AI Vanguard Masterclass, where we transition from theoretical frameworks to practical enterprise integration strategies. In our previous sessions, we focused entirely on large language models, systems fundamentally restricted to processing and generating text. While text is the foundation of corporate data, human intelligence and enterprise operations are not strictly limited to the written word. We operate in a highly complex, multimodal environment, constantly synthesizing visual cues, auditory signals, and spatial awareness simultaneously for artificial intelligence to truly act as an autonomous enterprise agent. It must possess the ability to process these diverse sensory inputs. This brings us to the next critical evolution in corporate technology, the deployment of true multimodal neural networks. A unimodal AI, like an early chatbot, operates in a sensory vacuum, blind and deaf to the physical and digital world around it. A multimodal AI, however, is architected to accept and process multiple different types of data formats simultaneously within a single cognitive engine. It can look at a live video feed, listen to spoken instructions, and cross-reference that input against a written technical manual. To understand how this functions, we must examine the underlying architecture, specifically the role of specialized data encoders. In a text-based model, words are converted into mathematical tokens that the transformer architecture can process and predict. Multimodal systems use highly specialized neural encoders to translate entirely different data types into a shared, universal mathematical language. For example, a vision encoder divides a high-resolution image into a grid of distinct patches, mapping their geometric and color relationships. It converts those visual patches into mathematical vectors, essentially translating the image into a format the language model can natively read. Similarly, an audio transducer captures the frequency, pitch, and temporal dynamics of human speech, converting sound waves into corresponding vector embeddings. These diverse data streams are not processed in isolated silos. They are projected into a single, unified, high-dimensional vector space. This allows the core transformer architecture to mathematically correlate a visual object, like a rusted pipe, with a spoken word damage. The system achieves cross-modal understanding, meaning it does not just recognize the image. It understands its semantic context in relation to the text. The practical implications of this unified architecture for modern digital transformation initiatives are absolutely staggering across all corporate sectors. Consider the manufacturing industry, where quality control has historically relied on isolated visual inspection cameras and separate diagnostic software. A multimodal network can simultaneously analyze the live video feed of an assembly line while monitoring the acoustic vibrations of the machinery. If it detects a visual microfracture and hears a specific auditory anomaly, it can immediately halt the line and generate a written diagnostic report. In the medical sector, these systems are revolutionizing diagnostic accuracy by cross-referencing patient history files with complex radiological imaging. The AI can read the doctor's written notes, analyze an MRI scan, and highlight subtle anomalies that a purely visual system might miss. In corporate IT and cybersecurity, multimodal models can monitor visual screen recordings of user behavior alongside raw network traffic logs. This provides a holistic security posture, detecting sophisticated insider threats by correlating physical visual access with digital data exfiltration. However, architecting and deploying these multimodal networks within a secure enterprise environment presents unique and complex infrastructural challenges. The computational power required to process high-definition video and audio simultaneously is exponentially greater than processing simple text tokens. Furthermore, storing and retrieving multimodal embeddings requires highly advanced, enterprise-grade vector databases capable of handling massive dimensional scaling. We must also address the critical issue of data privacy, as audio and video feeds often capture highly sensitive, personally identifiable information. Deploying these systems requires strict algorithmic governance, ensuring that visual and auditory data is anonymized before reaching the cognitive engine. As technical leaders, you must audit your current infrastructure to determine if your data pipelines can support multimodal ingestion. You cannot simply plug a camera into a legacy language model and expect the system to achieve spatial awareness or operational safety. You must engineer secure APIs that funnel sensory data through the correct encoders before it enters your corporate cloud environment. The transition to multimodal intelligence represents the death of the traditional graphical user interface as the primary method of computing. We are moving towards spatial and conversational computing, where we interact with enterprise systems exactly as we interact with human colleagues. You will no longer navigate complex software menus. You will simply show the AI a problem through a lens and ask for a solution. This marks the foundational stepping stone toward the deployment of fully autonomous AI agents capable of independent operational execution. An autonomous agent cannot successfully navigate a complex digital or physical workflow if it is blind to the interface it is operating within. By mastering multimodal neural networks today, you are laying the necessary infrastructure for the autonomous corporate workforce of tomorrow. You are equipping your enterprise with the cognitive architecture required to perceive, synthesize, and react to the world in real time. This is not merely an upgrade to your existing software stack. It is a fundamental re-engineering of corporate operational capabilities. To assist your engineering teams in navigating this complex architectural transition, I have prepared a comprehensive multimodal technical guide. This documentation details the specific vision encoders, audio transducers, and unified vector space architectures we have discussed in this session. It outlines the computational requirements and data privacy protocols necessary for securely deploying these systems in a production environment. It also includes practical, step-by-step architectural diagrams for integrating multimodal APIs with your existing retrieval augmented generation pipelines. You can access this critical technical documentation immediately in the professional GitHub repository linked directly in the video description below. I highly encourage you to review these materials with your data architecture teams to ensure your infrastructure is prepared for this evolution. The companies that successfully integrate multimodal intelligence will achieve unprecedented levels of operational efficiency and strategic market agility. Those who remain restricted to unimodal text processing will find their digital transformation initiatives severely limited in the coming years. As we conclude this session, prepare your technical infrastructure for the shift from passive data analysis to active sensory perception. In our next masterclass session, we will explore exactly how these multimodal capabilities power the evolution of autonomous AI agents. We will examine the advanced frameworks required to transition from systems that simply answer questions to systems that independently execute complex workflows. We will deconstruct the specific architecture of multi-agent collaboration, where specialized AI models work together to achieve overarching corporate objectives. Ensure your engineering teams have mastered the foundations of generative models, RAG architecture, and multimodal processing before we take that leap. Building the AI vanguard requires a rigorous, continuous commitment to understanding the most advanced underlying mechanics of modern cognitive computing. Master the architecture of sight, sound, and text synthesis to command the future of enterprise technology and secure digital innovation. The future belongs to those who architect the infrastructure, not just those who interact with the final user interface. Subscribe to the masterclass, download the comprehensive GitHub technical guide below, and join the vanguard. Thank you for your time.